Maths Masterclass with Leo. Let me teach you a bit of math.
Let me teach you a bit of math, okay?
In this channel, we'll be dealing with learners who are in grade 10, grade 11 and grade 12. We'll be dealing with learners who are below average, average and above average. Actually, when you talk about learners who are below average, you're talking about from level 1 to level 3 learners. Average, you're talking about level 3 to level 4. And then above average, you're talking about level 5 to level 7. We'll also be dealing with learners who want to rewrite maths. They've been struggling with maths. And then we'll be dealing with ways to answer questions, how to attempt questions, how to actually pass maths. And then we'll be dealing with question papers, paper 1 and paper 2. You know those simple chapters in paper 1 when you talk about the average learners or below average learners. You know those questions. And then when we talk about paper 2, you know those questions, you know those chapters, statistics, and so forth and so on. Okay, welcome back to it. It's Maths Masterclass with Leo. Today we are doing geometric patterns. Please don't forget to subscribe and hit that notification bell for more videos like this one. And make sure you go check the previous videos that I posted about number patterns. If you still have a problem with number patterns, you can just comment down below and then we'll get back to you. And today we are doing a very important one. It's number pattern, which is the geometric one. Now we're doing the geometric. It's very important as well because you never know which question they want to ask you on number patterns, so you need to know all of them, the three of them: the linear, the quadratic and the geometric. This one is a bit tricky one if you have problems with exponents, but if you don't have problems with exponents, you can just answer this one very easily. If you have a problem with exponents, just go back to the first video that I did. It was basically on algebra and we did the laws of exponents. I hope you enjoy this one. Let's get to it. Okay, similar to the other ones that we did, geometric pattern also have the general equation. The general equation, that is the general equation of the geometric pattern, right? Where your A represents your T1 and then your R represents a common ratio, right? The two that we did, it was the first one, the linear, it was the common difference. The second one, we did the first common difference and the second common difference. Now we are talking about the common ratio, right? You know your N represents your position, right? And then we have a formula to calculate the value of R, which is equals to T2 subtract T1, right? We also have these things. A, this is your T1, then AR, this is your T2, then AR squared, this is your T3, so forth and so on, right? This is how it continues until infinity. Then now we also have, similar to the one that we did on the first linear pattern, we also have Sn into R to the power n minus 1. Remember, quadratic does not have Sn. This is all over R minus 1, right? Or you can write it like this. You have another one that says Sn equals to A into 1 minus R to the power n, close bracket, divided by 1 minus R, right? And then you also have another one. This is where in the cases of infinity, you have A over 1 minus R, where these things work whenever your R is in between -1 and 1. All these rules, these ones from here to here, actually they apply when your R is in between -1 and +1, right? And then we also have the sum of TK, which is your that, right? And then let me just take a quick question about geometric. Okay, we have our question. It's given us, okay, the pattern 2, 6, 18 and 54. We're given this pattern Definitely is a quadratic pattern, not a quadratic but a geometric pattern since you are doing geometrics. Okay, now the first question, it says we need to determine the next two terms. That is our first question. Next two terms, right? Then how am I going to determine the next two terms? But I definitely know I need to know the common ratio of this thing so that I can continue with the pattern, right? If I don't know the common ratio, I cannot continue with the pattern. So how am I going to calculate my common ratio? Common ratio is equal to T2 divided by T1. What is my T2? It's 6. What is my T1? It's 2. This all they give me 3, right? Okay, if you can, just to prove, you can just calculate T3 over T2. Then what is T3? It's 18. T2, it's 6. This gives us 3. Okay, we have a common difference. It means when I want to move from here to here, I'm going to say 2 times 3, it's 6. 6 times 3, 18. 18 times 3, 54. Now, what is 54 times 3? 54 times 3, where's my calculator? 54 multiplied by 3, it's 162. You see? Then it means my next term here will be 162. Right? And then 162 multiplied by 3, it's 486. 486. There. Right? This is how we continue. Okay. If you are wondering, why do I say multiply? Why do I say multiply? Let me show you from this formula. I'm just going to say, oh, I have the value of r, right? What is my value of r? It's 3. Then check here. This is my term 1, term 2, term 3, term 4. I need term 5 and term 6, right? So for me to get term 5, I can just say r is equals to term number 5 divided by term number 4. Right? Because this is 1, 2, 3, 4. Term number 4, right? What is r? R is 3. What is term number 4? We don't have term number 5, but we have term number 4, which is it's 54. Right? And then I'm just going to say here, cross multiply, then it's going to be 3 multiplied by 54. This is equals to T5, giving me 162. This is T5. See, similarly, when I want to calculate T6, I'm just going to say R is equals to T6 divided by T5. What is my T? What is my R? It's 3. T6, I don't have it. T5, 162. Then 3 multiplied by 162 is equals to T6. Then 486, yes, equals to T6. There. This is how I calculate it. That is why you see me say, you heard me saying, actually, 2 multiplied by 3, 4 multiplied by 3, because of my common ratio. Right? Let's move to the next question. It says we need to determine the nth term. This is the second question. Determine the nth term. By now you know the nth term. They talk about the general formula. General formula. Right? By now you know this. If you've been watching my previous videos, then now let's get to it. But I know my general formula for this one. It's Tn equals to AR minus n minus 1. This is supposed to be r here. N minus 1. It's like that. Actually, let me just write it so that you see it. It's Tn equals to AR n minus 1. There's my formula. But I need to know this for me to determine or to write my formula. I need to know the value of A. I already have the value of R, of which I calculated somewhere at the top there. Then now I need to know the value of A. How can I calculate the value of A? Okay, now this is where your basic comes in. If you forgot your basic, you are out. Remember, A, it is the first term. A is my first term, right? So I can just substitute here the value of A. What is my value of A in the pattern? I believe the value of A, it was 2. Yes, the value of A is 2. Then I'm just going to say, oh, Tn is equals to 2. Then into, what is the value of R? It's 3 to the power n minus 1. There's my equation. There is my simple equation, right? Now, if you want to prove your equation, you can just say, oh, okay, what is my first term? 2 into 3 to the power 1 minus 1. 1 minus 1, there's my first term. You see, there is my first term. Let me just put 2 here. You'll see it's supposed to give us 6. 6, continue, supposed to give us 18. See, therefore, my equation is correct because when I substitute T1, I get 2, T2, I get 6, T3, I get 18. Then let's just take T5, see if it will give us 162. There. See, T6, see if it will give us 486. It's 486, right? Okay, let's continue. The next question, they need us, we are required to calculate the 20th term of the sequence, right? By now you know this, the 20th term, it is the position, right? This 20, it is the position, it represents the value of n. N is your position. This 20 represents the value of n, and n is your position. Now you have your formula. You can just say T20 equals to 2 into 3 to the power 20, subtract 1, right? What is the answer to that? Then I'm just going to say 2 into 3 to the power 20 minus 1. There's my answer. Don't know if it's, yeah, you know, numbers will show you. It's 23, 24, 23, 24, 52, 29, I believe. It's 29, 34. 229, 34. How many numbers are here? 2, 4, 6, 8, 10. 10 is a what? Yeah. You know your numbers, you know your millions and what, and quadrillions and stuff like that. We are not there. We are here. Right, let's attack the next question. Now, the next question says, which term is 13, 1, 2, 2? Which term is equal to that, right? Now, they need the position. We are required to calculate the position here. We are required to calculate the position. We have Tn. This is the value of Tn. This is the term, right? We need this n, right? But remember, your equation is Tn is equals to 2 into 3 to the power n minus 1. We are looking for this. We're looking for that guy, right? Now, I have Tn, which is 13, that, right? 13,122 equals to 2 to the power 2, 3 to the power n minus 1. But simple mathematics, I can just remove this. Remove this, simple mathematics. Then 13, 122 divided by 2, I'm getting 6561 is equals to 3 to the power n minus 1. If I'm here, what can I do? What can I do if I'm here? Let me see if I can just say 6561 shift. Oh, simple mathematics. Then remember, you can just say 6561 equals to shift factors. Oh, 3 to the power 8. I have 3 to the power 8 is equals to 3 to the power n minus 1. Simple mathematics. Right now, if I'm here, remember, I said if you understand the laws of exponents, it's easy for you to understand geometrics, right? So now, if you are here, if you forgot this, you are out. So just go back and watch my first video. It was based on the, algebra. We were doing laws of exponents. Okay, now, if I'm here, I can just drop this. I'll have 8 is equals to n minus 1, right? Then 8 plus 1 is equals to n. Therefore, n is equals to 9. Is my n legit? Is the value of n legit? Yes, of course it's legit. Why? My value of n is positive. N is a whole number. It's positive, it's a whole number. Your n can never be a fraction, nor negative. Right? Now, let's go to the next question. I just took Random questions again. I have this one. This is question A. They say 3.3, 6, and 12. Okay, this is the pattern that we're given, and they say, what do we need to calculate? We need to determine the 10th term. We need to determine the 10th term of the sequence. Okay, determine 10th term of the sequence, right? But you know, if you need to determine the 10th term of the sequence, what you need to do, you need to know your equation. You need to know your formula, right? Otherwise, if you don't want to use a formula, you can just go step by step, okay, and calculate the value of r. You can multiply and multiply until you get to the 10th term, of which is a long process, right? Okay, now I can just say r is equals to t2 divided by t1. What is the value of r? T2 is 6, t1 is 3. This will just give me 2, right? Even if I say t3 divided by t2, I'm still gonna get 12 over 6, 2, just to prove or to confirm that this is a geometric sequence, right? Then now, if I have something like this, oh, okay, now I can just say, I can either use the equation or the formula Tn is equals to ARn minus 1, which the value of A is 3, because A is your first term, always. A will always be your first term, right? Then now, I can just say Tn is equals to, what is A? Is 3, into, what is the value of R? It's 2 to the power n minus 1, right? Now I can just say, oh, T10 is 3 into 2 to the power 10 minus 1. Then I can get the value of T10. 3 into 2 to the power, what am I doing? To the power 10 minus 1. There, I have 1536. That is my T10. Some people just say, I don't like using the formula. I'll just go manual. Okay. T4, I'm just going to say, I have 3, I have 6, I have 12. And then T4, I'm just going to say 12 times 2, I believe is going to give you 24. T5, I'm just going to say 25 times 2, I believe is going to give you 48. Let me just make sure. Yes, and then 48 times 2, it's 96. We are on 1, 2, 3, 4, 5, 6. And then 96 times 2, it's 192. Right, and then 192 multiplied by 2, it's 384. We're on term 1, 2, 3, 4, 5, 6, 7, 8. This multiplied by 2, it's 7, 6, 8. Multiplied by 2, 1, 5, 3, 6. This is T10. If you can count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Some people will just say, nah, I don't want to use the formula. I'll just go the manual way. This is a long way. See, but it will give you the same answer. Right? Okay, now let's go to the next question. The next question, it's also geometric. I'm just going to say here, I'm given, do they say determine, this is B, this determine the number of terms. If you are given 2, 4, 8, 10, 24. We're given that. They say determine the number of terms in this sequence. How are you going to determine the number of terms in this sequence? Okay, now let's go to it. Let me just get the space. Okay, now we are given this sequence. This sequence, it's, let me just rewrite it. It's 2, it's 4, it's 8. And then we are given the last term, which is 10, 24. Right, we are given this sequence. They say determine the number of terms in this sequence. It means this is the last term. If this is the last term, you need to determine how many sequences are there, right? Okay, now what you need to do, you need to just say r is equals to t2 over t1. What do you need to do? You need to calculate the tn, or the nth term, right? The equation. After calculating the equation, you can just substitute this because this is your tn, and then after putting this as your tn, you can calculate the value of n, right? Then after getting the value of n, you'll get that is the position. After getting that position, you'll be knowing how many terms you have in the sequence. Okay, looking at the position. Now, T2, this is T2, I have 4 over 2, this will just give me 2. Okay, let me just make sure R is equal to T3 over T2. What is T3? It's 8, T2 it's 4, then this is equals to 2 as well, right? Okay, now I can just say Tn is equals to A Rn minus 1. What is A? A is always my first term. A is always my first term. What is my first term in that case? It's 2. R, I got it as 2. N minus 1. And then I have that, but I know the last term. This is my last term, which is the Tn as well. I can just write it as 10, 24. And then 2 into 2n minus 1. Simple mathematics, simple mathematics. This and this will cancel. Okay, 10, 24 divided by 2. It's 5, 12, which is equals to 2 to the power n minus 1. What is this? Can just go straight to my calculator. 512 is equals to shift fact. 2 to the power 9. Simple mathematics. Simple exponents. 2 to the power n minus 1. And then 9 is equals to n minus 1. Then take this to the other side. 9 plus 1 is equals to n. Then therefore the value of n is equals to 10. Therefore there are there are 10 terms in this sequence. Right? We have 10 terms in the sequence. Let's take the next question. It's a bit tricky, but not difficult. It's a bit tricky. Maths is not difficult. Maths is just challenging. Just make sure you practice maths regularly for you to understand maths. If you're given 5 is to x is to 45, right? They say these are the first three terms of your sequence. Determine the value of x. Right? Okay, I know r is equals to t2 over t1, right? Then what is my t2? It's x. What is my t1? It's 45, right? This is the value of r. This is my first equation, because I have two unknowns, right? I have two unknowns. That is why I use this. I say this is my first equation. Okay, r is equals to t3 over t2. What is my t3? It's, what did I do? This is supposed to be that. This is supposed to be t3 over t2, and then this is supposed to be t2 over t1, because I have x. Okay, let me just cancel this, rewrite it in a correct way. It's supposed to be r is equals to x sub over 5. This is my first equation. Sorry about that. Second equation, r is equals to t3 over t2. What is my t3? T3 is 45. T2 is x, right? Now, this is my second equation. Then now I can just say, equate the equations. Equate the equations. Equation 1 and 2. Right? We equate them. We're going to have something like x over 5 is equals to 45 over x. Multiply this and this is x squared. This and this is Just 45 multiplied by x. 45 multiplied by 5 is 225. 225. Right? Then what is the square root of 225? X is equals to what is the value of x is equals to, I believe it's gonna be 15. Yes, it's 15. Right? There's my answer. Right? Then now, looking at this, again we're gonna have this is the square root, this is the square root, this is supposed to be plus minus, right? But at the end you're just gonna conclude and say, therefore, my x is positive. Why is my x positive? Why is my x positive? Because if you look at this pattern, it's an increasing pattern. You have 5, you have 45, means it continues like that. Okay, now let's take the last question for the day, and then we're gonna take question papers in the next video. Let me just pause it and get a clean sheet. Okay, I got a very nice answer, a nice question that I like, and I've always wanted to do one question with you guys. Determine, they say determine the geometric sequence with, or whose, not with, whose eighth term is 9 and 10th term is 25. Right? Given that, they say term number 8 is equals to 9. Term number 25, term number 10 is equal to 25. Right? Remember, let me just use a different color. Remember this. They say A is my T1. Right? AR is my T2. Right? AR squared is my T3. AR to the power 4 is my T. Yeah. AR to the power 3 is my T4. AR to the power 4 is my T5. It continues like that, the pattern, right? It means if I have such a pattern, it means my AR to the power 7 is my T8. If you can continue with this pattern like that. And then it means again, if my pattern continues like this, my AR to the power 9 is equal to my T10. Right? If the pattern continues like that. Okay, now this is just knowledge. This is almost there on every grade 12's textbook, right? You just have to know it. They're not gonna give you such things on your equations or on your formula sheets, right? You just have to know them, right? Now remember this T8. I was told T8 is 9. It means T8 I can just substitute 9 and say I have AR to the power 7, right? This can be my first equation, right? Remember I was told that T10 is equal to 25. I can just say 25 equals to AR to the power 9, right? That is my second equation, right? If you have something like this, what can you do to solve it? You know, if it was me, I was just going to say, oh, I can just say T2 divided by T1, right? T2 divided by T1, it means I'm going to have something like 25 divided by 9 equals to AR to the power 9 divided by AR to the power 7. Oh, this one and this one cancel, right? I'm just going to say this will give me 25 over 9, right? Okay, I have R to the power 9 over R to the power 7. Laws of exponents. If you forgot the laws of exponents, go to my first video. You're going to get them. Now, I have 25 over 9 equals to Now the laws of exponents, it says when I have a to the power n divided by a to the power m, it will give me a to the power n minus m, right? Similarly here, I'm going to have r to the power 9 minus 7, right? And then this will give me 25 over 9 is equals to, what is this? This will give me r to the power 2. Now I need the value of r, introduce this guy. Then now, the square root of 25, it's 5, right? The square root of 9, it's 3. This is equals to my r. Now, right? If I have this, then I can determine my value of a. What is the value of a? I can just say, oh, take one, substitute r in one of the two equations. Let me just take the first equation. I have 9 is equals to a r to the power 7, right? Then I can just say 9 is equals to, what is a? I don't have it. What is r? I have it. 5 over 3 to the power 7, right? Then just divide by 5 over 3 to the power 7, divide by 5 over 3 to the power 7. This and this cancels. Therefore, what is the value of a? The value of a, you can just say 9 divided by 5 over 3 all to the power 7. I have the value of a at 0 point something. Is it legit? Let me just check if it's legit. Yes, that is my answer. That is my answer, right? Then I can just write it and say, this can just be 9 multiplied by, okay, let me just leave it here and say, therefore a is equals to 9 over 5 over 3 all to the power 7, right? Then they said determine the what you call the, what is the question again? Let's just go back. Determine the geometric sequence. At least let's get 2, right? Let's get 2 more of this, just to so that we can have a sequence, right? Now we got a, which was our value of a. Then this is t1. T1 is 9 over 5 over 3 to the power 7. This we can multiply it by r, which is 5 over 3, and then we will get the next term, which is t2. T2 is equal to okay, 9 over 5 over 3 to the power 7 multiplied by 5 over 3. Then you can just write it and say, okay, the next one will just be, okay, 9 over 5 over 3 to the power 7. I don't want to write them because they are decimals, right? Then let's just, you multiply it by that. You're going to get the next one. And then the third one is just going to be this. Okay, it's 9 over 5 over 3 to the power 7 multiplied by 5 over 3 multiplied by 5 over 3 again. This will be my third term. This is how my sequence will go, right? Hope you understand. Make sure you click that subscribe button and you like. Most of all, enjoy my videos, and if you have a problem, just comment down so that we can just sort out the issue. Thank you.